In this video, we just shall look at how we are going to solve our sum of subsets problem with the help of our backtracking approach. Okay, so initially we just shall look at our backtracking approach. So backtracking approach is a kind of an approach which just identifies a particular component for a given period of time. And then what it does is that it just travels in the particular component and then it just finds out the answer. So which means that it just identifies a given component and then it just travels in the same way to find out the optimal solution for it. If the particular path doesn't lead to your optimal solution, what it does is that it just backtracks, which means that it just moves a component behind or a component back and then it just continues in its path. So this is how your backtracking algorithm works. So right now we just shall look at the problem description of your sum of subset problem. So sum of subset problem, what you will be presented with is you will be presented with a set of elements, which means a set of positive integer numbers, and then you will be also given with a particular sum. So what you have to do is that you just have to identify whether the given sum will be made by the combinations of the given elements inside the set. So this is how your sum of subset problem works, and then we just shall look at it with the help of an example. So here consider this example. So here the given subset is 3, 5, 6 and 7, and then d is equals to 15, so which is nothing but it is the maximum, or this is the sum which we have to obtain out of the given subset. Right. So how we are just going to travel is we are just going to construct a state space tree diagram for it. So since we just know that backtracking algorithm always solves your problem with the help of your state space tree, so we will be just starting with the initial condition, and once after the initial condition we just will move on a component based component manner. Okay, so initially I'm just going to construct the state space tree. So for constructing the state space tree, so I just go with the initial condition. So my initial condition, there is no element inside it, so I'm just marking it as 0, right? So once after it, what I have to do is that I just have to frame a particular tree such a way that whether I'm just going to include these elements or not. Okay, so for example, I just begin with 3 over here. Okay, so what I do is that I just construct a tree such a way that I'm just taking 3 with me. So I'm just marking with the 3, I am just moving and I am just traveling without 3. So my sum will be the vertex node, which means 3 is I am just taking the sum of it. So initially my sum is equals to 0, right? The first node what I have taken, I just have taken 3. So what I do, I just travel with 3. So whenever I am just traveling with 3, my sum has become 3. Okay, so without 3 I am just traveling means my sum will be already 0. It will be 0 right here. Okay, so the next level of the tree, what we have to do is that we just have to take the next element and then we just have to travel further, right? So here what I do, so similarly I am just constructing another level, so which means that I am taking with 5 and then without 5, right? So already my sum is 3 right now. So with 5 if I am just traveling, my sum will become 8, and then without 5 means my sum will be 3, right? So similarly for the other side of the tree also, so you just have to construct, right? So here what I'm doing, I'm just making another thing with the 5, right? I'm just traveling without 5, right? So with without 5 my value will be 0, with 5 my value will be 5, right? So similarly for the next element we are just going to take 6, right? So we just have to construct our tree further. So here what I do, I just construct another level of it, so which means with the 6 I'm just going to travel and then I'm just going to travel without 6, right? So with 6 if I am just traveling, my value will be 6 plus 8, obviously it will turn out to 14, right? So without 6 it will be 8, so I'm just marking 8 as such, right? So the next step what I'm doing is that I'm just marking for the next element, which is nothing but my 3 over here, right? So here again with the 6, without 6 I just have to travel, right? So with 6 my value will be 9, without 6 my value will be 3. So similarly here what I have to do, I just have to travel like that. So here I just have to consider with the 6 and then I'm just going to consider without 6. So with 6 the value will be 6 plus 5, obviously 11. Without 6 the value will be 5. So here with the 6 the value will be 6, right? So without 6 my value will be 0. Okay, so what is the next step we have to do? We just have to go for another level. So which means that we are going to travel for the element 7, right? So here we just have to consider it. So here if we am just considering 7 over here, my value will be greater than 15. So what I do, I am just leaving it off. So with this what I am doing, so for with 7, I'm just leaving it off. Why? Because it is greater than 15, so I'm just leaving it off. So without what happens is that, so without my value is 14, so I'm just keeping it as is. So without 7, I'm just keeping. So because if there is any other element, we could travel. If there is no other element, we will just leave it off or stop over here, right? So considering this problem, we will be stopping it over here. Why? Because there are no further elements, right? So again, what we have to do, we have to consider with and without. So here with 7, I'm just considering my with 7, my value is going to be 15, and here I just have obtained my solution, which is nothing but 15. Okay, so we cannot stop right here. Why? Because we have identified the solution. Some other problem might lead to it. So we have to complete the entire state space tree. So we just shall consider without 8, the value will be 8, right? So here with 7, without 7. So with 7, my value will be 16. I'm just leaving it off. Without 7, my value will be 9. I'm just leaving it off. This is also I just have left off. So similarly here with 7, without 7. Right, so with 7 my value will be 10, so I just cannot consider it. Without, the value will be 3, so I cannot consider it. So similarly here with 7 the value will be 18, without the value will be 11, so I cannot consider it. So similarly likewise 7 plus 5, so we will be getting around 12, so I cannot consider it. Without, the value will be 5, I cannot consider it. So 6, again with 6, 12, 13, I cannot consider it. So without 6, okay, and then the value will be 7, I cannot consider it. So and again the value will be 0, I cannot consider it. So the optimal solution which you have obtained for it is only one path. So why I have completed this is, so there might be opportunity such a way that some other value might lead to 15. So you cannot stop when you identify the when you identify one of the feasible solution, right? So what you have to do, you just have to complete it and make sure that no other path exists. Okay, so once after considering it, what you have to do is that you just have to backtrack it to the source such a way that you are just going to identify the subset. Okay, so here my subset will be what I have done. So I'm just having my value as 15, so total value I just have obtained as 15. So how I have obtained it, so I have obtained it with 7. So with 7 I'm just marking 7, right? I'm just having without 7, so without 7 I'm just not marking anything. And then again backtracking it, I'm just traveling it with 5, so I'm just adding with 5, right? So the next element with 3, I'm just taking it out, so I'm just taking with 3. So this is the subset which we have obtained for reaching our 15. Okay, so for reaching our answer 15, we have to include 7, 5 and 3 such a way that the sum of subset is being achieved. So this is how you just solve the sum of subset problem with the help of a backtracking approach.